Let f of x equal x squared minus 4 and g of x equal x minus 1. Find and simplify completely. So, g evaluated at f of x is our first one, which is the same as g of f of x. F of x goes into the parentheses, and since f of x is x squared minus 4, g of x squared minus 4 is what we end up with. Then we evaluate g of x, which is x minus 1, by replacing all the x's with x squared minus 4, the same as you normally would. So, x squared minus 4 minus 1 is what we end up with. And then we simplify that by combining negative 4 and negative 1 to get negative 5. So in the end, g evaluated at f of x equals x squared minus 5. In B, we have f evaluated at g of x, which is the same as f of g of x. G of x goes in the parentheses. Since g of x is x minus 1, we have f of x minus 1. Putting x minus 1 into all the x's of f of x, which is x squared minus 4, we end up with x minus 1 squared minus 4. We simplify that by multiplying out x minus 1 squared to get x squared minus 2x plus 1, and then subtracting that final 4. Simplifying that further, we end up with x squared minus 2x minus 3. So f evaluated at g of x equals x squared minus 2x minus 3. In C, we have g of x, which is equal to g of x. In the parentheses, we put g of x, which is x minus 1, and then we evaluate g at x minus 1 by replacing all the x's in g with x minus 1. G is x minus 1, so the x becomes x minus 1, and then minus 1. So, by simplifying that, we end up with g evaluated at g of x equals x minus 2. And then, finally, we have f evaluated at f of x, which is equal to f of x, which is equal to f times x squared minus 4 by putting f of x into the parentheses. And then we simply put x squared minus 4 into all the x's in f of x, meaning we end up with x squared minus 4 squared minus 4. We simplify that by multiplying out x squared minus 4 squared to get x to the 4th minus 8x squared plus 16, and subtracting the final 4. Further simplified, that is x to the 4th minus 8x squared plus 12. So f of evaluated at f of x equals x to the 4th minus 8x squared plus 12.